Okay, so here we are, day 2 with chapter 7 of correlation, and what we're going to start with is we're going to start with freshman year GPA in college and SAT scores, math and verbal. Now this is old SAT scores because what we're talking about is just the math and verbal without the writing content included, which means you're looking at a score out of 1600, and here's freshman year in college, freshman year GPA. And what we're going to do is we're going to graph this on the calculator because it's convenient and we need to know how to do it. So let's do that. Let's start by bringing up the calculator. Here we are with the calculator. And in order to do this, we're going to have to put the data in the calculator. The data will be available on the wiki. So find the wiki and look for a Excel spreadsheet, and I'll also put it in Word. It'll just be called data, I'm assuming. And what we'll do is that data will be in L1 and L2. So we'll go to Stat, our favorite button, and Edit. And we will see that here in L1 and L2, we're going to have the SAT scores for math and verbal and the freshman year GPA. And we're going to find that relationship and look at it. So what we need to do is we need to graph this. What type of graph we're going to make? Well, of course, we're going to make a scatter plot. So let's go to Stat Plot. And when we go to Stat Plot, we're going to just have one plot on and one plot only, not like with a box and whisker plot or a box plot where we can have two plots side by side. We're going to have just one plot going on here. So we're going to hit Enter, and here's the scatter plot. It's the very first plot that we're going to use, and the default that comes up is for your X list to be L1 and your Y list to be L2. So what we need to do is determine which one of these is going to be our explanatory variable, which one is going to be our response variable, otherwise known as X and Y independent dependent. And it would make sense as we think about what we're looking at here. We've got SAT scores and we've got freshman year GPA. Since SAT scores normally happen in your junior, possibly senior year of high school, it would make sense that those would happen first and freshman year GPA in college would happen later. And it makes sense because you know you got to get accepted to college in order to get a freshman year GPA. So you want your SAT score probably to be first. So what we'll do is we will put that information in as our independent or explanatory variable, and we'll put our freshman year GPA in as our dependent or response variable. So my SAT scores are in L1, my freshman year GPA is in L2, and we will go and plot this. And of course, because my window is probably messed up due to I grabbed something else, in order to make this quick and dirty, zoom, stat, zoom 9, and there's our graph. So as we're looking at this graph, we need to describe it, and we're going to describe this relationship with three things. First thing is form. Form means shape, and basically we're talking, is it linear or not? Does it have a linear trend? I would say yes, it does. It most certainly does. It's moving in a linear pattern. Second thing we need to talk about is direction. Direction here, it's positive. We have a positive correlation as X increases, Y increases. But positive is not enough information. We need to put it in context, talk about what X is doing, what Y is doing. And X happens to be SAT scores, Y happens to be freshman year GPA. So our complete response here, Regis, would be that as it's positive, and as SAT scores increase, freshman year GPA increases. There you go, that's the answer you want to give. Third thing we want to do is we want to give an estimate as to the strength. Now this looks like it's a pretty decent relationship. And since SAT is a decent, not the best, but it's a decent predictor of how you're going to do in college, hence that's probably why colleges use them, and because it makes money for the college board, haha. It makes sense that it would be a decent predictor, so there should be a decent relationship here. So our strength here is going to be pretty strong, and it turns out that it's actually 0.816 as we're going to look and find out how to do that. But because you're not expected to know exactly what it is, if you gave a value somewhere probably between 0.5 and 0.9, that would be acceptable. 0.5 means that there's kind of like a moderate relationship here, and you should be able to recognize that that's a fairly moderate relationship. 0.9 is going to be a really strong relationship, certainly not stronger than 0.9, because if it was like 0.1, it would be a line, and it's not. So you should recognize that, yes, there is a relationship. It's fairly looking kind of strong, so it should be between 0.5 and 0.9. Those would probably be acceptable answers as far as what you could give for strength. Okay, so how do we find that correlation coefficient? Well, one thing that we could do is we could use the formula for the correlation coefficient, and the formula for the correlation coefficient is R is equal to the summation of z sub x times z sub 1 divided by n minus 1. You will probably never, ever, ever have to do that by hand or in this manner, because you will be given the calculator and you might in some way have to, given this information, find something out. But you will not have to do this by hand. Probably fairly never-ish. You never know. Okay, but there's the actual formula right there. Of course, since technology is wonderful and we love our calculator, and yes, my calculator loves me, I'm going to let my calculator do this for me. So as I look at this, I'm going to calculate. So I'm going to go my favorite button in the whole world, which is stat. And of course I'm doing a calculation, so I'm going to go over to calculation. And now I'm going to do linear regression ax plus b, or if we look at number 8 is a plus bx. And as we said before, it doesn't really matter which one you choose. This is in the form y equals mx plus b, where a is the slope and b is the y-intercept. This is in the form a plus bx, where a is the y-intercept and b is the slope. Mathematician form, statistician form. Mathematician form, statistician form. Let's go with number 8. I always use 8. That's because we'll see that in the next chapter why I always do that. Alright, so here I go. I'm going to do it for L1, comma, L2, where my data happens to be. I'm going to hit enter, and I'm going to get 4 pieces of information. I'm going to get the y-intercept, the slope, I'm going to get r, the correlation coefficient, and I'm going to get r squared, which happens to be, I don't know what a surprise is, r times r. That'll be a valuable piece of information to us later. What's that, you say? You don't have r and r squared. Foolish child, let's fix that. So if you don't have r and r squared, that means that you need to turn on the diagnostics on your calculator. Very simple fix. Here's what you're going to do. You're going to go to the catalog, which lists every single possible variable and combination and column program and whatever in there. You do that by hitting second and 0, and it brings up the entire catalog. And what we're looking for, it does, really, there it is. Whoa! So we're looking at this, and what we need to do is we need to turn the diagnostics on. So we're looking for diagnostics. Yep, we're looking for diagnostics on. And we can scroll all the way down to D, but that would take forever. So what we're going to do is we're going to hit the matrix button here, or the inverse x button, x to the negative 1 power, which also happens to be the letter D. I'll hit that, and that'll take me to the very first D, which is day of the week. I really want to try this function. So we're going to scroll down to diagnostic on. It's somewhere around 7 or 8 down. Diagnostic off, diagnostic on. Went one too far. Diagnostic on. I'm going to hit enter. It's going to go to the main screen. Diagnostic on. Hit enter again. Hey, I'm done. Okay, now I'm all set. So now if I do stat, and if you do stat, and we do calculate, and linear regression, a plus bx for L1, comma, L2, we get the results that we need. Okay, now, again, because this is a plus bx, not ax plus b, because this is listed as a plus bx, a is going to be my y-intercept, which is negative 1.14669111697. And my slope is 0.0039340275. Correlation coefficient 0.816, which means my strength here of my correlation is 0.82. Again, that's a pretty strong relationship. This was the information that we were looking for right here, 0.81. And now we have it. Okay, now, going back and thinking about the formula here for a second. R is equal to, correlation coefficient is equal to the summation of z sub x, z sub y over n minus 1. Z plays an important part of this. And z is equal to, what? Z is equal to, alright, let's do it together. X sub I minus the mean over the standard deviation. So what I would have to do is I would have to do the z-score for every single one of my x values. And what are my x values? Well, my x values would be the SAT scores. And I'd have to do that for all of my y values. And then I would have to multiply each x z-score and each y z-score together and then sum them up. Yes, that's a lot of work. I don't want to do it. Neither do you.